back, chemistry fans. Okay, so we are going to start with topic 5, unit 5, topic 2. This is how we split our redox reactions into half reactions. Let's get into this. It shouldn't take us that long to get through this portion of the topic. It's the next class where we have a whole lot to cover in a short amount of time. Okay, so what we have learned so far is how to assign oxidation states, oxidation numbers, charges to these, and then relating that back to the definition of the fact that if you lose electrons, you are oxidizing. So this one went from a 0 to a +3. That means it lost 3 electrons. However, the oxygen in this case starts with 0 and it goes to -2. That means it has gained electrons. That means it went reduction. And that's the only skill that we need to master today. So again, these definitions, oxidation means you lose electron, you become more positive. Reduction means you gain electrons, you become more negative. So a half reaction is simply taking a completed reaction, and that would be on this step number 3 down here. And then you split it up into the individual. You see that iron is the one that is changing its charge, becoming more positive, and so that means it goes oxidation. The cerium went and it became more negative. Now, it doesn't become a negative value, but it becomes more negative. It comes closer to negative. It went from a +4 down to a +3. It's getting closer to 0, and so that means that it underwent reduction. So now, coupled along with this is the idea that we have to be able to identify if you have lost electrons. That means you went through reduction, but because you're going through reduction, you must cause oxidation. So oxidizing agents are the ones that actually undergo reduction. Reducing agents are the materials that actually undergo oxidation. And I know that that is a little bit confusing. So here we are again. If zinc goes from a 0 to a +2, that means it lost electrons. That means it underwent oxidation, meaning that it is the reducing agent. If the copper becomes more negative, that means it underwent reduction, and it is now an oxidizing agent. The oxidizing and reduction agents are always on the left side as reactants. They are never products. So let's take a look now of a couple of examples here and see if we can identify what are the agents. So in this case, the sulfur has gone from a -2 to a +4. That means it has lost electrons. So it underwent oxidation. The oxygen has gone from a 0 to a -2. That means it has gained electrons. It has gone through reduction. Now, I don't identify the individual elements as the agents. It's the entire substance. The H2S is the reducing agent. The O2 is the oxidizing agent. So we have to identify the entire substance as being the agents. Let's do one more here. Manganese is going from a +4 to a +2. That means it's gaining electrons. That means it undergoes reduction. The oxygen is staying at -2, so it's not doing anything. The chlorine didn't change. It's the chlorine did change in one instance. The hydrogen did not change. The chlorine goes from a -1, and in one instance, it stayed -1, but the other, it went to 0. That means it is undergoing oxidation. So we must now identify that manganese dioxide, MnO2, if it's going, the manganese is going through reduction, this is my oxidizing agent. If my chlorine is the material that undergoes oxidation, the entire HCl is the reducing agent. All right, let's practice now the splitting up into these half reactions. So I'm going to take one of these examples here, and we are going to split it up, and then we can go back to doing some more practice later if we need to. All right, so in this scenario, elements by themselves are 0. On the left side, the iron goes +3, the oxygen goes -2. So the iron went and it lost electrons. So the half reaction on this one is going to be the 4 irons with a 0 producing 2Fe2O3 and it's going to have, well, you know what? We're just going to split this up into 4 ions like we did before. And it's going to lose 12 electrons. Now, my other half reaction, it's going to be the oxygen. 3 O2s with 0 are going to go to 6 oxygen ions. And because it is gaining electrons, it had to gain those 12 electrons from somewhere. So we have 2 half reactions now split up appropriately because of what they went through. Let's try one more, and then we're going to call it quits. Now, this last one, number 7, is a little bit more complex. So we have to figure out what the charges are on each one of the elements before we can move forward. Now, my oxygens, they're not changing. They're all -2 because none of those oxygens are by themselves. None of them are diatomic, making them peroxides. My hydrogens, same way, +1, +1, so they did not change. So it looks like we're either down to copper or sulfur or sodium. Sodium has a rule, it's going to stay as +1, so nothing is happening there. So let's try and figure out what my charges are for the copper. Now, I know that sulfate has an overall charge of -2. That means this charge is going to be +2. On the left side, oh wait, this one did not change. That's right. I remember this from class. So let's do number 6. Let's split up number 6. So magnesium is going to have a charge of 0 on the left +2 on the right. The oxygen is going to go from 0 to -2. So it's a little bit easier on this one to see that the magnesium is going from a 0 to +2. It is losing electrons. So I am going to write this out. And it is going to lose 2 electrons, 4 electrons. Sorry, 2 electrons. Now, the oxygen is going to go from O2 to 2 oxygen ions. Now, it gained 2 electrons, so its electrons are going to go on the left. Okay, this is everything that I wish to help you with on how to write half reactions and how to identify the agents that are involved. So thank you very much for your time. I will talk with you again soon. Farewell.